Hey everybody, how's it going? This is Gabriel Cardona, developer evangelist from Ava Labs. Thank you so much for joining us for the very first ever Avalanche Community Developer Call. We're hoping to do these on the regular so that we can connect with our community of developers and answer questions and just keep you guys up to date on all the amazing things that are happening in the engineering team at Ava Labs. We're very fortunate today to be joined by three of our best engineers. We have Patrick, our director of engineering. We have Stephen Butoff, the creator of Avalanche Go and the director of the platform team. And then we have Aaron, the creator of Core ETH and Subnet EVM, and one of the guys behind Precompiles and a bunch of other amazing stuff. So basically now I'm going to pass the mic over to Patrick so that he can give us a recap of all the amazing stuff that's happening. Thank you, guys.
Cool. Thanks, Gabriel. Yeah, welcome, everybody. We've been planning for a call like this for a while now. So Aaron has been running some beta test calls over the last few weeks. So thanks to him for helping us get to this point with some of the community. But the natural next step is opening it up for anyone to join in. And so the dev community calls are really going to be about a few things, recapping recent releases and stuff like that have gone out. So, we write Twitter threads and we write blog posts, but talking about, recent things like that will be one part of it. The other part is talking about what's to come. So like, what are the primary things that we're developing right now and like, what are their targets? And then lastly, basically questions. So community topics people want to discuss that we'll collect ahead of time. So if you saw the Google form, you can submit anything there you'd like to discuss, and we'll bring people up onto the call to ask those questions or join us in a discussion about anything. And so we may invite other groups here to join us. And the real goal is let's increase the basically the participation in the open source tooling on Avalanche. And so trying to align everybody to make sure that we're all working on the best stuff and make sure that we're all aware of what's going on. So yeah, so today joined by Stephen and Aaron, who I often take a lot of credit for their work that they do. So it's great to get them up here to tell you themselves some of the awesome stuff they've been working on. And so first off, I think we'll just kick off with a quick, well, not even just a quick, but a recap of the recent releases that we've been pursuing on Avalanche Go. So I'll share my screen now with some of those things. So Stephen, maybe you want to kick us off with BAMF 10, Avalanche Go 1910.
Yeah, so right now Avalanche Go are really pushing for trying to get ready for 110x. So we're trying to push for that next network upgrade. But 1910 focused a lot on some additional kind of MerkleDB improvements. So the MerkleDB is this kind of experimental database that we've been using to power the Hyper SDK. So that we get really fast authenticated storage to support state sync out of the box. So a lot of the work for BAMF 10 has been around that area, but we're also kind of cleaning up some other things. We had a 199 release that did a major refactor of how we manage plugins. So we had a couple improvements with that as well with respect to like signal handling and things like that. And then the last thing I think that we really worked on in here that's of note is adding more warp support. So we added some like BLS public keys into the Snow context so that underlying VMs know kind of the area or like the environment that they're executing under, so they can kind of better support warp messaging. Yeah, I think that that's kind of the main things. There's a bunch of cleanup things like that, but that's that's kind of the BAMF 10 release that we did. We had to do eventually a fast follow for BAMF 11 because we actually actually broke some of the RPC chain VM stuff, or the plugin processing stuff, because of how we were handling some like logging of registering of the VMs. So we ended up fast following that for people that were running subnets. But those are kind of the last two releases. Yeah, I think right now kind of Avalanche Go, we're pushing really hard on 110x. So yeah.
Yeah, the convenient thing with getting that fast fallout is we did get two awesome new features in, which was one, there's actually an embedded wallet inside of Avalanche Go that powers like the Avalanche CLI and a number of other things. And we only were able to sign transactions by hash using Ledger with that wallet. And thanks to the new Zondax-powered Ledger app and some stuff that one of our engineers, Felipe, did, we were able to now add an integration where we can actually do the proper transaction signing on Ledger, so it'll actually parse the messages, which is a huge improvement for UX and safety as people deploy subnets, which, obviously having the control keys for subnets is extremely powerful. So the more security and safety we can provide, and that is critical. And then naturally with the MerkleDB, it's an experimental project, so we're constantly improving it performance-wise and shipping it. And so if you want to take a look at what we're actually changing, if you go to the X directory inside of Avalanche Go, so I'll give you a quick tour here. If you go to the X directory inside of Avalanche Go, this new X thing, you'll see the X package where we have 2 experimental packages that we're kind of we're incubating right now. And inside of the MerkleDB one, you can see all of this stuff, but there's a huge to-do list. You can see that it's still underway because the to-do list comes before the introduction. So that's usually a good sign that there's some work to be done. But if you want to get involved or understand what's going on, you can check this out. So we've just been kind of burning through this list as we prepare and work with the Hyper SDK to prepare for some really cool Hyper SDK devnets. So on that note, so we have the releases here. I just wanted to highlight one more thing. And that was the Warp UX improvements. So I'll talk about this later on in this call, but with a lot of the work we're doing with the Hyper SDK, with Warp integration, it's showing areas where we can improve the interface with Avalanche Go to make it easier for any virtual machine to actually generate and verify Warp messages. And so this was one of the ones that came up while I was working on that, was 2 things. One, the signatures they're basically interfaces, the Warp signatures. And so you can call verify on that interface, but we did not expose the ability to get the number of signers that were actually participating. And so when you're trying to verify a Warp message, because of the way multi-signature BLS works, the more signers there are, typically the more expensive it is to actually perform that verification. And so if you're trying to charge fees for the import of Warp messages, you want to know how many signers there were. And then secondly, adding the BLS public key to the Snow context lets you identify yourself when you're trying to fetch Warp messages and also sign your message and store it in a way that makes sense. And so that's really useful for actually spinning up, how this all works. And so again, I'll cover a little bit more of that later on. But I think the big fix there was improved RPC chain handling that kind of followed from this big change, which I think, let me see if I have a separate picture of, because there's something I'd like to show. Let me pull up one more slide deck here. 1 second. Thought I had all the tabs open.
Yeah, I feel like we'll probably want to refactor some of the signature interface stuff to be more kind of like how we handle verification of other transactions and the X chain or the P chain, because that way you can just kind of define your own execution logic as the VM.
Yeah.
So we'll probably end up modifying that a bit, but at least for the short term, I'm definitely happy with just adding that num signers to kind of expose cost tracking. Yeah.
Yeah. So the other thing, I just want to provide some basic context around the gRPC handler changes we've been pursuing. And so you may be wondering, well, why are you doing this? It worked fine before. What is there to change? So previously, we were using a tool produced by HashiCorp, which is, we've been relying on for years. So it's great that that project was out there, called Go Plugin. Now, Go Plugin is this really nifty tool where you can basically connect Go binaries running in different processes to each other over gRPC. And well, actually, really, the process you're connecting to doesn't have to be Go based at all. It just has to communicate over the standard gRPC interface. It's much better supported if it's Golang, but there are ways to do it where it doesn't have to be Golang. And so what that allows you to do is what they use it for is fault isolation. So if the process you're connecting to dies, it won't kill the whole thing. And it also it's just nice to you can have different languages kind of running within Go in an interesting way. but we were using it to really run the virtual machine binary itself, whether that be Golang or Rust or anything like that. And it was useful to get started, but there were a lot of things that it forced you to do on a very particular way. You couldn't control the way signals were sent to some things. You couldn't control the way you could like kind of connect and instantiate different gRPC connections. But most importantly, because of the way the initial handshake worked, it assumed that there was a Unix socket that you could communicate with, or like a socket you could communicate with on the same host with the destination binary you're trying to spin up, which in a world where Avalanche Go will be more of a cluster operator, it was a hard blocker, right? So like if you wanted to spin up a binary on a separate host and use this sort of plugin orchestrator, it was not possible. And so as we're preparing for like the evolution of Avalanche Go, which allows you to run subnets and chains on different hosts, it became critical to be able to have much more control over the gRPC connections that Avalanche Go forms. And so by removing Go plugin and replacing it with our own homegrown solution, we're now unblocked to do things like this. And so to give you some idea of what we think about, right, is, okay, you know, Avalanche Go, let's say you're running one subnet, maybe not too high throughput, and you're running, you know, the primary network. You can probably run that on a single host, not really any problem, right? But now let's say you run 5 subnets, or you know you have a bunch of different subnets you want to participate in. Well, very quickly you're going to run into the bottlenecks of a single host, or like you're going to have a huge. It's just going to be complex to run all these things on the same process. And so what you probably want is actually to create like a cluster of different hosts running different chains. And so what'll happen is like hopefully Avalanche Go will become eventually more of like a cluster operator, where like Avalanche Go, the primary network, will still run on a single host, but then for any subnet, maybe it is on an external host, which has its own disk or like has special tailored networking for whatever you're doing. And so it's just more about the sustainable and evolving future of what you can do with subnets. So I just wanted to focus on that. Cool. So that's the Avalanche Go related stuff. And now I'll turn it over to Aaron, who has been focusing more on our EVM related projects. So this is Subnet EVM and Core ETH. Aaron, I'll turn it over to you. Do you want me to focus on Subnet EVM first, or do you want me to pull up Core ETH?
Definitely Subnet EVM. If you could scroll back to V0410, actually.
Yep.
So this one is a super small line here that's not really written out into exactly what it is, but this was actually a huge refactor that we worked on for a really long time. So huge shout out to Jay, who did most of the work on this. But this was breaking out our precompiles, which we've been working on for just under a year now. That a lot of people are familiar with, but they're basically this ability to add plug and play functionality directly into the EVM. And so we've started out building these by building specific functionality that a couple of different people requested that you wouldn't necessarily be able to build directly into the EVM. So these are mostly admin type functionalities, things like who is allowed to send a transaction to the EVM, who is allowed to deploy a contract, as well as playing around with the fee config and changing who actually is receiving the rewards from all of the fees on the subnet. And so we've built all these precompiles out over the past year. And we basically built them out one by one, all inside of the same package, which ended up becoming a little bit spaghetti-like. And so this was a big effort to basically reorganize all of this code into individual modules that we could then register and operate with very, very easily. So this is, you can see this nearly 6,000 line PR here. It was reorganizing all of this code. And the really nice thing about this change is that what we ended up doing was making them individual modules, so you can actually register one externally. So this is actually opening up the door as well to make it so that you can actually build your own custom precompile and then register it into Subnet EVM. So this will basically unblock custom precompile development without actually requiring that you fork Subnet EVM. So we're still sort of working out exactly what we think the best way to do this is. There are a couple of different options that we're sort of exploring. And if anybody has any ideas, definitely open to them. But what we're really trying to get is to a system where you can not have to fork Subnet EVM and only have to worry about implementing your own precompile modules in order to implement your precompile, and then just register them directly into Subnet EVM without worrying about any additional overhead at all. And so ideally, this means that that precompile repo does not need to change unless we either make a breaking change to that interface, which would obviously require that you change your code a little bit, or if you actually want to add or modify one of your precompiles. So this ideally means that they stay in place and you don't even need to bump the subnet EVM dependency. So that for if you're deploying your code, the only thing you have to update is subnet EVM, and you won't actually have to update this repo at all, as long as you're not making any deeper changes. So that's sort of the goal that we're going for here. And if we're able to get that, then it'll make it a really, really nice developer experience for anybody that wants to actually go and build their own custom precompile, build it once, and then use it, forever. And so this is really like for us, kind of like the next step in our vision of making subnet EVM like a really easy to use developer toolbox for modifying the EVM. So precompiles are obviously a big part of that. Some other things that could be cool in the future are allowing you to hook directly into the networking layer, something that supports something like libp2p, plugging directly into the transaction pool and adding your own verification type stuff in there. And there are a couple of different people that are playing around with stuff like this. So if you have any ideas about things that would make subnet EVM easier to work with, or added features that you might like, definitely make a feature request on subnet EVM. Hoping this is just the beginning of a conversation around what would be useful tooling to build into it.
Yeah, the other upcoming feature obviously is all this time we're spending on adding warp related support to the subnet EVM 2, which has been an ongoing effort for a few months now. I'm not sure if Aaron, you want to touch on on how you're thinking about that.
Sure. Yeah, I can go into detail here, or I can just talk about it really quickly.
I think like at a high level, I think understanding what what kind of messages you'd interact with to actually use it would be interesting. Like, what is the interaction path? If not maybe how it works per se, but more so like what a developer that's deploying a contract or doing something like that would expect to interface with.
Yeah, so this will work very similar to our other precompilers, where there's going to be some interface that's defined directly in Solidity. And so all that you're going to have to do to send a message from chain A to chain B is just specify sort of the chain ID in that warp message and specify whatever payload that you might want. So it's going to look like you're calling a contract. It's basically going to look very, very similar to if you were using Layer 0 to just send a message to some other recipient on another chain. And you can specify both the destination chain ID, which is going to be the Avalanche blockchain ID as opposed to the normal ETH chain ID, and then also the address that it should be sending it to on the recipient chain, and then a payload of whatever bytes message that you might want. And so we'll end up building layers on top of that will take care of things like fees on the other chain, incentivization. But this will basically build out the functionality to verify the message was actually signed via warp from Avalanche Go. And so you can have these verifiable messages. So you could actually build this out as a sort of a middleware layer into a lot of the other developer tooling that exists now. So you could use this in order to basically say that, yes, this is an authenticated message that actually came from another chain, and we have these signatures to prove it. So it should be a pretty simple interface. And there's actually a PR up right now with some of the main ideas in this. Yeah, it should look pretty simple, and you could do this to do things like bridging here's the internal repo. But yeah, this is an earlier version of what it was going to look like. So it's changed a little bit since then. But yeah, so this is something that you could use to implement bridging in order to move assets from chain A to chain B, as well as from the C chain to a subnet. And then this could also be used to do anything like generic messaging, whether that be for cross-chain governance or anything else. Or if you want to migrate some work from the C chain to another chain and have a VM be incentivized to deliver that back to the main chain, you can also do something like that.
Yeah, I mean, I think that at a high level, like the actual hooking up to Warp is pretty straightforward, right? Because it's just a blob, and Avalanche Go handles verification, right? The complexity is three things, in my opinion. One is, how do you actually express the contents of the warp message in a way that makes sense for the virtual machine? So like making this feel very EVM-like, even though it's very much not EVM-like, is very important to actually make it usable. Second of all, the incentivization. So like, why are people submitting these things, especially if you're going to a subnet EVM that you don't have assets on, right? Like, can you compensate, someone for relaying your message or something like that? And then the last one is really related to standardization. So if you have different types of virtual machines, maybe there's a balance between actually what you need to do to make things compatible with everybody versus what is best for the virtual machine itself. And so there can just be a lot of complexity as you get through that. So it's one of those situations where I feel like a week after Warp launch, we had like a basic POC. And then now over the last, almost 3 months, it's been great. Now, how can we make that actually more usable? So this is a classic dilemma we've run into things like this. Yeah, Steven, I saw you unmuted, or actually, Aaron, go ahead first.
Yeah, the main complexity with integrating this into the EVM is really the fact that in the EVM, you do not depend on any external state when you're processing a block. And so what that means is that if you're processing some transaction, the EVM state is the only thing in the block itself is the only thing that impacts what that state transition actually is. With warp messaging, that's actually no longer the case. And the reason for that is that in order to verify one of these messages, it actually depends on the P chain state itself. So the P chain state is where, and Steven can talk about this more, this is where the subnet validator sets are all defined. So the cool thing about, and yeah, Steven can definitely talk about this more, but the cool thing about, here's a great diagram. Because the P chain maintains all of the validator sets of every single subnet, this is really the core of how warp messaging works. And the cool thing about building a subnet where you are actually also validating the primary network is every subnet validator is required to also validate the primary network. And what that means is that you can essentially use the primary network in order to make sure that you have knowledge of what the validator set is of any other subnet that you might want to talk to. So in a lot of other bridging solutions, you might actually need to have some sort of light client in order to verify some event that happened on another chain in order to have like a knowledge of what happens there. In Avalanche, what we do with warp messaging is essentially use the P chain as the light client for every type of subnet to subnet messaging, where instead of actually having to validate what happened on another chain, all you have to do is know what is the validator set of that other subnet in order to be able to verify a BLS multi-signature or a warp message that came from there. And so this is a very cool design. This means that in order to make this state transition within the EVM, we're actually going to depend on this external state, which is the P chain, which is sort of an anti-pattern in the EVM. People are generally pretty happy that they've avoided this within the EVM. But for us, we actually need to integrate this piece of external state in order to handle that, in order to handle these warp messages. And so the way that we've basically figured out how to do this is that we are going to have a predicate on the transaction itself, and the predicate will essentially be encoded in this thing called an access list of a transaction, which is typically used to pre-specify individual storage slots within the EVM that should be preloaded into the cache in advance of the transaction's execution. And so we're sort of stealing this mechanism in order to specify the predicate that corresponds to a specific address. And in the case that somebody specifies an address of this warp precompile, it will essentially parse that and interpret it as a signed warp message, and then try to verify that in advance of executing the transaction. And so it's going to basically validate this predicate in advance of the transactions that inside of the EVM's execution, it can assume that predicate has already been validated. And therefore, inside of the EVM's execution, it won't depend on any sort of external state, and it will only be in this predicate verification that the external state impacts the execution. And the nice thing about this is that whenever we need to reprocess a block or reprocess a transaction, as long as we know that the network accepted it at some point, we know that predicate was also validated at the time that it was accepted. And so this is essentially the assumption that we use in order to support things like bootstrapping when that P chain state may no longer be available for fast lookups, as well as API executions that depend on re-executing the EVM state at say 1,000, 2,000, or however many blocks ago. That P chain state may no longer be easily accessible. And so the fact that we can assume those predicates were validated at that time means that we can just index into the messages that were verified and assume that they're valid without actually redoing that verification. So that's essentially like the weird bastardization that we had to do in order to make this work safely inside of the EVM, which comes with lots of interesting work that goes into it. And that's really the difficult part about this, as opposed to actually integrating warp itself. Like Avalanche Go has made this actually like incredibly easy. All you really have to do, as Patrick has said, is you just verify this signature, parse the message, and then spit it out. There's a little bit more work that we've done around incentivization, around what that UI should look like, and some changes that we might make in Avalanche Go to make that even easier to use. But the main thing is really just this: how do you actually validate these things safely, and how do you try to do this in as EVM native of a way as possible? And one of the things that's taken, we spent a lot of time on, this is something we do a lot at Ava Labs, is try and figure out exactly what the best way to do this is. And we definitely did a lot of experimentation with different ways to do this, because this external state mechanism is sort of weird. And so we were trying to look at, all of the different ways that we might implement it, and what's going to end up having the best developer experience. So one of the big things here is that having to specify this access list is one way of doing things. Another way that we also thought about was actually storing whether or not so this was actually a suggestion from Steven, which is that although this does depend on some piece of external state, the P chain height is actually specified in the proposer VM's block header. And so once you specify that, you know exactly whether a message is going to be considered valid or not at that height. So one thing that we could do in order to enable us to reprocess blocks historically, both from the API and from bootstrapping, is to actually populate that block while you're validating it with which messages were hits or misses, so you know exactly which messages should be considered valid. So I was experimenting with this week, and it ended up being a little bit, it was a bigger bastardization of the EVM than we would like to make, is the way I'll put it. So even though it was a really cool thing that would remove some of the, it would remove some of the overhead from user transactions, it ended up that looking at it, I sort of thought that it would probably be better to require these specific transactions be built in this way using the access list than to change the EVM so deeply, because that's something that we try and avoid doing, is changing the EVM too deeply in a way that's not intended, in order to avoid a situation where we break some invariant or break away from the original Geth code too much, such that makes future changes or migrating Geth, upstream Geth changes at some later point more difficult to deal with.
Yep.
Yeah.
Steven, I saw you on mute. I don't know if there's anything you want to add to that.
No, yeah, I just think that like one interesting thing that we're going to have to keep in mind as we continue through this is there's probably going to be, or as soon as we release Warp on Subnet EVM, there's probably going to be people asking about like how they could integrate like Subnet EVM with a non-Subnet EVM VM. And so you had raised an interesting question about kind of where we would like start speccing out like the actual like message specs that we're using for like cross-chain interaction. And so I think that could be like an interesting thing to kind of like think about on like where we would actually do that specifying of things. Like, do we want to specify like kind of like abstract protocols where there's not actually a concrete implementation, but like sub implementation? So I know that so Warp is at a high level completely agnostic to pretty much everything message, right? All it cares about is that there's bytes and then there's the attestation, right, from that VM. But we could definitely dig in a little bit more on those bytes to set up some like canonical, like, oh, you have like an address, maybe you have like an amount, like things like that. And we could fully specify some different kind of simple communication formats. We haven't really gone too deep into that. I'm not sure exactly where we would want to put that, whether that would just be kind of like a spec with like a reference implementation and put that somewhere, or whether or not we would want to like have more full support for it. But yeah, so that's definitely something we're keeping in mind as well. And then there's also like, do we want to have like, something with an address and then another arbitrary payload? That might be a little more weird, because then like you still have to end up implementing a concrete payload at the end of the day. But yeah, so I'm just kind of like been thinking about how we want to really start standardizing some of these protocols, because yeah, like communicating with two different instances of the same VM is one thing, but we're going to get into the situation where people are going to start using standards to communicate across different VMs as well. So
yeah, for sure. This is for subnet EVM, it's not just talking. So I think the current implementation in Avalanche Go specifies a source chain and destination chain, which is all that you really need to know. Beyond that, the things that subnet EVM is also going to include in that Warp payload is the source address. So that from subnet EVM's perspective, which address on the EVM, whether a smart contract or an EOA, actually sent the message, and then also the destination address. So if it's sending to it's itself on another chain or a different address on another chain, what address is that actually? And so that's going to be, an interesting thing to see how that correlates to something like a hyper VM, the index VM, token VM, et cetera. So I've been messaging Patrick about this the past week or so about hey, like what's the format on Hyper SDK?
What a great segue! Yeah, so
segue,
we can go right into the Hyper SDK with that one. So, yeah, so this is a great bleed into kind of doing a quick recap of where we're at on the Hyper SDK side, and then like the kind of work we've been doing over the last week to integrate Warp. So you may get a theme from all these conversations, which is like we're very interested in Warp right now and think it's a huge improvement for the Avalanche ecosystem and Avalanche network. And you may be wondering, like, why are we spending so much time on it? Well, like after we released the Warp specification in 1.9.5 or BAMP 5 for Avalanche Go, Steven sent the first Warp message on mainnet. But since then, not a lot of Warp messages have gone across. And the reason for that is, it's complete in Avalanche Go, the spec, or at least in terms of the reference implementation, but in terms of actually using it in a virtual machine, we have a simple demonstration virtual machine called the XSVM you can check out, which is open source. But it's very limited. It just does some basic token stuff and movement around. And so actually integrating Warp into a virtual machine or an SDK in a way that makes it practically useful for what you're doing is critically important. Naturally, the follow-up question to that is also, well, cool, it's in this VM SDKs on subnets. What about the primary network? How can I go between the primary network and subnets, which is, a whole nother topic and focus to cover, which we will, for now, delay. So the reason for that is, it's incredibly important to go between the two. But first, we want to make sure it works well within subnets. And then from subnets to the primary network, we think that it will take the best learnings we have from working with subnets and subnet communication to bring it to the mainnet, right? Because naturally, subnets very easy to spin up and down and play around with and do whatever, right? Main network, where everyone is validating on the primary network, much more difficult to change and something that you change less frequently just to minimize risk. So we want to be really sure the way we're doing it is the right way, especially with some of the optimizations Aaron's talking about to avoid re-verification of Warp messages to make it safe and fast enough for the primary network. So it's very much something that will exist and will be added to the ability to go from a subnet back to the primary network using some sort of standard message format, but not initially. So initially, we're going to focus just on making it really easy to go between different subnets, and then we'll focus on making it easy to go between different types of subnets, and then we'll focus on going from there to the primary network. And so what I think will happen in terms of a network topology is that most people will find a way to get assets and value to subnets, or that assets and value will just be native to the subnet. And then it'll be really easy to move between different subnets, potentially easier to do that than to go between the primary network and subnets. And then once we really like that flow and it's integrated into core and everything like that, then I think it'll be rolled out with basically connecting the primary network back. So, if you're on this call, that if you say Avalanche, the second word you probably say is subnets. So for that reason, subnets are the scaling mechanism for Avalanche. The primary network is primarily concerned with orchestrating subnets, and doing it this way is the right way to actually push the scaling of it. Now, people may say oh, there's a lot of activity on the primary network you want to connect. I totally agree with that. And I think that that's just a reflection of the growth of Avalanche rather than the way that maybe scaling will go over the next few years. So I think that being subnet native is going to be very important for the growth of what we're doing. And so a lot of the code we're writing is about really making subnet super powered so that you can do all this sort of stuff. And that's where the Hyper SDK comes in. So you've seen me posting about the Hyper SDK over the last few weeks, different sort of things we've been doing. And we've also started this thing called the Hyper SDK Journal. If you want to follow along on Twitter I've been posting development updates, and everyone that's been working on it has been posting development updates. And so the vision here, just, the quick 30-second overview, right? Two things. One, the logo is awesome. So that's pretty cool, top notch. And then the other one is that we built the Hyper SDK because a lot of people were coming to us saying, you talk about all this custom virtual machine stuff you can do on Avalanche, and I love it. It's great. But where do I get started? It's kind of hard. There's almost too many choices. It's I think the term is the paralysis paradox, where you have so many choices that it's impossible to make any choice, even if you have so much freedom. And so the Hyper SDK is about, all right, what if we make a bunch of choices for you that we think are really good, and then you just build on what we say you can build on. And it's still super generic. Like you can do almost anything on this thing, but maybe some decisions are made for you that behind the scenes just make your life easier. And so if you check out the Hyper SDK, README and documentary, or not documentary, we don't have that yet, but maybe someday, documentation of what's going on here, you can read in detail about some of those features that are really important to us. And I'm just going to highlight a few for the people that, maybe want a higher level understanding of what's going on here. And I feel like I've talked about this a lot lately, so I'm not going to belabor the point. I think you can watch any number of previous chats I've had, but it all starts with really efficient state management and state syncing. That's the basis for the Hyper SDK. And so it's all built on top of the MerkleDB, which is what we talked about earlier. And I joke around internally that the Hyper SDK is just a very thin layer on top of the MerkleDB, because in the way I view blockchains, it's really just it's a state machine, right? And the faster you can manipulate that state and the faster you can sync that state to new participants determines how much state you can manipulate. Pretty simple. Everything else with the Hyper SDK is really just like how you actually authenticate changes and determine how those changes occur. But if you can't do the state part fast, it's not really worth it. So for a lot of the stuff that we're doing with the Hyper SDK, it's all built on that foundation. And so if you're interested in building, and contributing to different database related stuff, the XMerkle database package is super interesting. And, we'll eventually bring that to both the X chain and the P chain to make syncing of the whole network faster. The other stuff I do is just, if I know exactly what transaction format you're going to produce, and like you tell me a little bit about what you're going to do, we can do a ton of optimization out of the box to make it really fast. So like if you say like your transaction is going to touch these keys, well, before I even execute your transaction, I can go fetch those keys for you. Similarly, if you tell me what keys you're going to touch, I also can know what transactions I can process at the same time without them conflicting with each other. Additionally, just the standard stuff with signature verification, right? So you kind of just go down the line of like, what are the biggest concerns people have run into over the last number of years? Let's figure out a way to do them in a way that you don't have to worry about. And then as a result, like the actual implementation you have to worry about is much less extreme. But as a result, we also throw in a couple quick, nice features, which are account abstraction. So first off, the entire authentication mechanism for the Hyper SDK is generic. So you can put anything in for account abstraction you want to, or like account authentication. So on my basic stuff, you can just have simple signature verification. But if you want to get complicated, you can have arbitrary interactions. All that the Hyper SDK says is like, give me an identifier for who's paying, and I'm going to ask them to pay some amount of fee for what they're doing. And if whatever your account abstraction can handle that, you can use whatever you want. So you could use ZK proofs. You could use, you could even use warp messages as an authentication mechanism on a destination, which is kind of nuts. So there's a lot of ways to experiment with this, and we're really excited to see where people go with it. And then lastly, the one a lot of people have had questions about, and I think is one of the coolest things, is this nonceless transaction feature. So if you've ever operated on top of a blockchain, especially EVM at scale, you'll realize you spend a ton of time managing nonces and replacing transactions and everything. Now, that's a simple way to ensure you don't have replays on a different network, which is great. However, it's super annoying to get right and super painful. And so what we do in the Hyper SDK is to entirely remove everything related to nonce tracking. So instead, you're basically limited to, for a single account, so a single abstract account, you can send one version of your message payload per second. And that's how uniqueness is defined. So if you send the exact same message at the same timestamp, you can't get that through. So what will happen is, like, if I'm sending to Steven and Aaron, they have different addresses. I can send both of them at the same time. And I frankly don't care what order they're executed in, right? I don't need to not nonce them such that they occur in a particular order. And so this sort of freedom is great for like server interactions, but also just generically wallets, right? You can expire transactions, and then you don't have to worry about like things getting stuck. If your transaction doesn't show up in 30 seconds, you can just be like, yep, I guess that's done. I'll try again.
To jump in and clarify just real quick there. You can send multiple transactions from the same account at the same time. Like there's not like a 1 second per account restriction.
Yep.
The comment is just that like if you're sending the exact same transaction, included in that transaction is the timestamp,
Yep.
and that is basically the hash of that transaction won't be allowed to be duplicated on chain. So that's, I just wanted to clarify that.
Yeah, that's a good point.
Like,
So yeah, the enforcement is just TXID uniqueness in the validity window. And the TXID hash is defined by the contents of that message. So if you send the exact same message multiple times in the validity window, naturally, like it's only going to get accepted once. But you know what that could mean very briefly, right? Is like if you send Steven the same amount of money 2 times at the exact same second, only one of those, like you can't do that twice, right? Because they're the same exact TXID. So that's the only one edge weird case with this, and which is minor. You can get around it. Like if you change the fee on one of those messages, both will go through, right? So as long as like you send messages that have unique hashes, then you're good to go. And so for many people, this is a massive improvement over what you currently do. And a lot of the complexity, if you look into the Hyper SDK, is for handling this case in the case where you're state syncing and everything like that to make sure you don't have replays. And so, but you know, long story short, very interesting to me and very interesting to the team to like get this out the door and continue to optimize it, because for a lot of people that want to do interesting things on blockchains, they need some basis to build on. And the Hyper SDK for Avalanche is a great basis to start. We'll have something similar with eventually the Rust related tooling we have, and have some very specific Rust related optimization SDKs as well for people that are doing that. So, you know, hold out a bit for that, and then you know, we'll get to that and cover that you know, in the next few weeks. But for now, the Hyper SDK is a great place to start if you want to learn at least how we think about what is an optimal virtual machine on Avalanche. And then for the last, I just wanted to touch on something for 30 seconds, which is how the Hyper SDK you know, handles warp, which I think is super interesting to visualize for people. So I'm implementing this as part of the token virtual machine. So, you know, here's my live walkthrough of like actually going to see this, which is in the Hyper SDK repo. There's a folder called examples. Within that, there's something called token VM. Now within the token VM, you know, it's a full virtual machine specification. You can run end-to-end tests. You can run end-to-end warp tests. So if you want to check out what those look like, just click this unit test button and you can look at the logs or run them locally. But what's cool is what the interface for actually integrating warp eventually looks like. So in this case, there are 2 warp-related interactions on the token VM. There's exporting an asset, and then there's importing an asset. Now, I haven't talked to this in depth with Steven or Aaron yet, so this is a live reaction to how good of a job I did. We'll see if they think it's good or not. So first off, when you export an asset, let me see if I can make this a little bit. I don't know why it's not doing a reaction. There we go. So when you're exporting an asset, you know, you can put anything in your warp payload, right? So you have to think about, well, what are things that would be interesting to actually include? The basics would be of a simple token virtual machine. You have a recipient, so a to address, the value, so like, you know, what you're actually, like how much of something you're sending, and then the asset you're sending if you have multiple assets, and then the destination. At a minimum, that's like what you need to really make it work. Now, I added a few extra things to make it a little bit more useful. And so those extra things are here. So first off, you can give a reward to whoever actually sends your message on the destination. So like, let's say you don't have an account there and you want to incentivize someone to send it for you. Well, if someone else sends it that's not you, they'll receive a reward of the asset you're bringing over, which for some people, you know, that can be really nice to have that integrated directly. The second part is the one that I'm really excited about. And this is the ability, as you bridge in or like warp into another subnet, you can specify an order that someone can fill to bring your message in that performs a swap to a different asset as you enter. So a big problem when you're doing cross-chain bridging is, great, I have assets on chain A and I'm trying to go to chain B where I have nothing. Well, if I bridge some token over, I can't bridge the native token over as a new thing. but I want the native token so I can pay fees. And so you can swap in your token, some amount of it, for some amount of some other asset that anyone that processes the transaction can fill for you. And then you can restrict it to say, if things change, prices are volatile, if the swap passes some expiry point, then you can process my message without actually performing the swap. And those are all optional parameters. So the whole point is, can we bootstrap like some sort of really interesting messaging complex without having to require a bunch of like really sophisticated relayers and hopefully include that logic in the chain, right? Because you could just as easily say, hey, like relayer, like Bill, like, can you just swap in when you get me there, like, and get me what you need? Well, unless it's an authenticated message, it's kind of tough to enforce. So it's cool that it's built in. But so what that looks like as a developer, right, is, this is my action for actually interacting with the Hyper SDK. And then here's my execution. A lot of it's boilerplate. I got to clean this up still, but like you have a chain result that emits if it's successful, the units used and the output. But the cool part is actually how you do the warp. So when you're creating a warp message, you just populate the warp message with the destination and the payload. So this is just my defined warp message here. And then you just tell the Hyper SDK, hey, here's my warp message. Take care of it. And so what it will do is persist it in state and then start to fetch signatures from all the validators behind the scenes to actually produce a valid aggregate warp message that then they can serve over its RPC for anyone to grab to put it on a destination. And so you as a warp user, all you have to do is basically give the Hyper SDK some arbitrary bytes you want to end up somewhere else and tell it where it wants to end up. And it just happens for you. And so then the import path is just the inverse of this, right? So instead, now I get this blob. So my warp message, I parse it as my warp transfer that I just exported. And then I operate on that after performing some basic validity checks. And the action, so this thing I'm executing, the Hyper SDK just tells you, hey, you said that was required. Here's the verification result. Was it an error or not? And so you can then use that to determine, basically what you're going to do within the action itself. So like if you have a warp message that fails verification for some reason, we still charge a fee on that as a DOS resistance mechanism. So like if someone comes in because like the verification actually requires like a BLS multi-signature, and if we just are like, hey, like drop anything that isn't a valid BLS multi-signature during the block or make it invalid, it's really easy for you to send us a bunch of blocks or like during the block building process for us to do a bunch of extra work. So if we start the process of verifying your warp message, we will charge you for that, no matter what it contains. And then the output or the result will only occur if it actually is successful. So that's a high level kind of. And so getting it to this point where like you basically just tell the Hyper SDK, here's my warp. And then the Hyper SDK tells you, hey, there's a warp message attached to this transaction. That took a lot of code. But I'm very happy with the result and what it actually will enable people to do. And so I know we have a number of great questions queued up, so I'm going to stop here and we're going to go. Basically, I'm going to produce a demo of how all this works with some really cool stuff over the next day or so that will give you an even better idea of what's going on. So I know, Stephen, you unmuted for a second. I don't know if there's anything you wanted to add there. There's a lot of content.
I guess, does the Hyper SDK doesn't support, or does it support a full sync from scratch? It doesn't, right?
Does.
It does.
Yeah,
How does
go ahead.
How does the warp result work? Is that like stored in the actual block?
Yeah, so the warp result Boolean. So this is one thing I have to change is the warp result right now is an error. I'm going to change it just to a bool that says if it's successful or not, and then those are stapled to the block.
Mm-hmm. Cool. Yeah.
All right. Thank you guys very much. Go for it. Finish your thought.
I was just going to say that. No, I'm echoing somewhere. So that was the basically the thing that Aaron was talking about a little bit earlier, but that we decided not to do in the subnet EVM because it would have been too much of a bastardization of the EVM. But for something that's much more Avalanche native in the Hyper SDK, I'm a fan of that design for sure.
I think this is something that comes up quite a bit as we're working on these different virtual machines, which is for virtual machines that are part of a different ecosystem and community, we can't just like break compatibility entirely to like go completely off the script, right? And I think that's one of the big reasons why like we support the EVM, but are super interested in the virtual machines that are native to Avalanche, because a lot of times we can't showcase a lot of like the cool shit you can do on Avalanche because it doesn't necessarily fit well into the EVM model. But obviously the EVM model is extremely like popular, and so it's important to still support it and add cool features that are compatible. But you know, after spending so many years working on this stuff, sometimes we just want to like kind of make it do the things we've always wanted it to do and not really worry about that problem. And, you know, maybe some of those best ideas will get back into like our EVM development somehow, but it's nice to do like Avalanche native development sometimes, because a lot of these tools we built are built to kind of be primitives and used broadly. They don't have to fit into the EVM framework. So we're really excited to get some dev nets up, but I could talk about this for hours. We may go a few minutes over with different Q&A related stuff, because I apologize for kind of digging in so deep here. But Gabriel, I'll let you take the lead there. Thank you.
Make sure I'm unmuted. All right. Thank you guys so much. That was incredibly in-depth. As you guys can see, we have absolutely amazing engineers at Ava Labs. And every single day in the Avalanche ecosystem, my brain is blown at least one time. So thank you, gentlemen, so much. We were going to do a DevRel update, but in the interest of time, we have tons of interesting questions from the community. So we'll do a DevRel update on the next call. So now we're going to bring up a few people, and then we have some questions and a doc we're going to fall back to. But first, I want to bring up Izzet, who has a couple questions. I think we're going to do one at a time, and then if we have time, we'll circle back. Hey, Izzet, what's your question?
Hi, guys. My first question is about I want to represent subnet native assets on C chain. So what is the best way for it?
Good question. So I'll bring up a quick document to kind of talk. Let me showcase one thing here. Important. All right, here we go. Let me know if you can show that, Kyle. Yeah, so this is a big UX thing that we are currently thinking through right now. And I think getting the community's feedback on it would be super interesting. So, you know, the complexity, just for the table stakes, right, is like, if you define an asset on a subnet and you use that to pay fees, well, you can't also define that on the primary network, right? Like there's not really a way to do that. And like, I think the hope with warp messaging eventually is that you can kind of have like multi-homed like native asset kind of, where maybe it's deployed on the C chain and then it also serves as the fee thing right now. But right now, the way you have to do that is really define it in both places. And so a lot of people have the question, well, like, you know, if I define my asset on the C chain, well, how do I like canonicalize it and connect it with the warp side of it? And so what we've seen, or like the subnet side of it. And so what we've seen people do is actually just in their district, like the token creation, have some percentage on the primary network and then just some percentage on the subnet itself, and then keep them separate properly, but understand that they're the same thing and almost like pegged to each other. Now, is this perfect? No, definitely not. But the reason why deploying a token or like your native token on the primary network is so important is that it allows you to do elastic subnets. And so we haven't really seen this played out much, but the big thing that will happen in the next few months is that people will start to basically turn their subnets that are currently POA into full proof of stake elastic subnets. And those full proof of stake elastic subnets need a staking token that's defined on the primary network to work correctly. Right now, they have to actually be defined on the X chain. And so you have to define an asset. That X chain asset then has to become the staking asset on the P chain for your primary asset. And so if you're not careful with how you do it, you know, it can be tough to then migrate to that. You then have to like maybe later on deploy your token on the X chain and then do it. And so one of the things we're going to do is allow you to take each ERC20 on the C chain and turn that into an asset that can be staked on the primary network on the P chain, so that you don't have to deploy your asset on the X chain. But right now, it only works for X chain deployed assets. So what ends up working really well, like the easiest design right now is to actually just assume that your network has two tokens, one that's like your staking token, and then one that is actually your gas token that lives on the subnet. Now, that clear delineation avoids having to do like this single swap movement between like the subnet and the primary network. But at the same time, obviously not everyone wants that. They want to have, one thing that everyone uses. And so we're still working on the best way to actually connect those two things to be the same unit of account and make it native. So you don't have to like rely on a third party or do some sort of like weird management behind the scenes to keep the supply in the same way. So unfortunately, my answer for you is like, there's a few ways to do it. The way people have done it primarily is just deploy it twice and like make it clear to the community that these are the two deployment events, and then you should be okay. But from the other side of it, we understand that the UX here could be improved quite dramatically and are very aware of that and thinking of ways to do that.
Yeah.
I was looking for the easy way for it, so I already created a bridge for it, but I think for now there's no easy way.
Well, I mean, so and Stephen, I'll turn to you in a second, but the real problem is that we really want to avoid having people have a bridge be in that path, because this is your native asset, right? So like if your native asset is also used to pay fees and then you bridge into the subnet and there's like a bridge compromise, well, now people can just mint unlimited of the native asset, right? And so that's one thing if it's like a custom token, but if it's a native asset, you can cause all sorts of harm, right? Like you can DOS the network, you can pay infinite fees on whatever transactions you want to. And so we understand that typically people use a bridge for that right now, but really the hope is we can enshrine that sort of function natively into the protocol so that you don't have to have that bridge functionality. And right now we can go one way with like VM2. So you can define an asset and then import it onto a subnet using something. We haven't really fleshed that out as much, making it easy to use, but the difficulty is going back. And we figured, let's not focus on like this one-way transfer if you can't go back, because people are going to be like, this isn't a solution, right? So we need to finish the map. But yeah, Stephen, go ahead.
Yeah, no, I think you can go ahead.
Sorry.
You're good.
For creating an Elastic subnet, I have to create asset on Xchain. So I want to represent this Xchain asset on C-chain actually.
Yeah, so I'll dive in here. So really the ideal situation for this, and I would say realistic usage of Elastic subnets is pretty much blocked on this, is first converting ERC20s on the C chain to native assets that can be staked on the P chain. And then the second being the interactions between the primary network and subnets for ERC20 bridging over Warp. So really those are like the two things that are needed in order to get this to work seamlessly. Pretty much anything else I consider a dirty hack in the meantime. So we're definitely very actively trying to add support for both of those things. I don't know how much we want to like dive into this, but I know that we've at least been playing around with the ERC20 to ANT token conversions. So
I don't know if it makes sense to dive in here, because I think we want to make sure that everyone that kind of queued up for a question we can get to. But I think we can continue this conversation in the next community call, because I understand it. Obviously, we all agree that it's extremely important to get to, and we're just making sure that we can kind of do it safely and in the right way for that. So I think for now, my recommendation, the simplest thing is just like, kind of define it twice. Unfortunately, you have it on the C chain, you have it on your, your subnet. And if that's not sufficient, then, using a bridge temporarily, I would never going to endorse using a bridge because of the security concerns there. But, from a UX perspective, certainly will make it feel like, I think, how you want it to feel. Yeah.
Okay.
Yeah.
But yeah, thank you for the question. Yeah.
Cool.
Yeah. Thanks so much, Izzet, for the question. So we're going to be bringing up our next question is going to come from OX Hagen. The floor is yours.
Yeah. Hello.
Hey.
Thanks for having me. I have a specific question regarding the Ethereum virtual machine. I'm really curious, how do you guys manage it to keep it up to date with upstream? I mean, it is a big monolith and you have to pull out certain things like consensus and gas mechanism and pull in some staking mechanism. And I'm always curious and thinking about how do you do this? Do you pick certain files one by one? Could you automate this for certain directories? Can you please say something about that? Thank you.
Okay, but
Great question.
before I let Aaron dive in, because I think this is an Aaron question, I do want to say that because this is the bio of my Twitter profile, and I do want to just clarify. There's a big difference between like Subnet EVM, Core ETH, and Avalanche Go. So Avalanche Go is the thing that manages all of the staking, all of the consensus, all of the P2P networking, things like that. And the Subnet EVM and Core ETH are definitions of a VM that hook into Avalanche Go. So Avalanche Go is actually a completely unrelated project with Go Ethereum. It's a totally built from scratch with it's not a fork of anything. So we don't really need to add any of those things to Geth or Go Ethereum. It's all just completely unrelated. The
Is it gone for anybody else?
Sorry, I'm getting paged. Hopefully it's not an issue. So that's where kind of the delineation goes. So I'll leave it to Aaron to talk about how we actually bring in changes from Go Ethereum to either Subnet EVM or Core ETH. But yeah, just wanted to first clarify that.
Yeah, so the answer to your question is yes, we do this. It's not fun. We don't like it. It's Avalanche Go is not a fork of Go Ethereum, and that's a great thing to not be a fork of Go Ethereum. And thus Steven's much lauded and celebrated Twitter bio, at least internally to the team. I don't know if other people appreciate the genius of that Twitter bio, but yeah. So Core ETH and Subnet EVM are pseudo forks of Go Ethereum. And so whenever Go Ethereum fixes a critical vulnerability, not every time, but a large amount of the time, it's applicable to Subnet EVM and Core ETH. And so typically, a lot of the time, if there is a critical problem, there will be some alert. They will let maintainers of different forks of the EVM clients know. And so we'll be able to fix those changes in advance of them being published or in advance of any type of public disclosure about what those vulnerabilities are. Additionally, sometimes these things will be patched silently. It really depends on the individual fix, and the Go Ethereum team has experimented with different best practices in terms of how they notify the community and different EVM maintainers and trying to figure out like what the most fair and safe way to do is. They're very good shepherds of the community, I would say is a good way to put it. And so they've experimented with different ways. And so sometimes these things will also be patched silently. And then, announced at some later point. And so for that reason, we try our best to stay up to date with the latest changes from Go Ethereum in case that there is anything that is security related that has been silently patched and that we might not immediately recognize, because oftentimes that would be the intention of the changes, that it's meant to be covered up to some extent. We have a good relationship with them, so I think this doesn't happen as much anymore, that things are silently patched without letting us know. But yes, we do keep up to date. Right now, we've fallen a few releases behind since post the merge, so we're catching up right now. And this does take a decent amount of work. It's pretty unfortunate that the way Core ETH was originally developed was not actually as a fork of Go Ethereum with the shared commit history. It was actually a copy paste job, and because of that result, we have some Go Ethereum libraries that are imported and some that are copy pasted over into these. Which is not great to work with. And normally you would just be able to do like a git merge when you have that shared commit history. Unfortunately, we can't do that with the way that things are right now. So we do a sort of an ugly process of copy pasting the changes over, and it takes a lot more engineering resources to do so than it would if we could apply a simple git merge. So we're actually, it's gotten to a point now where post the merge, the Go Ethereum team has started to speed up a little bit. So we're looking into potentially some solutions that'll sort of automate this process. I think the ideal one would for them to be actually to have a shared commit history so we could more easily apply these changes. But that's also a big project because we've come all this way, not having set it up that way. So that is a big project with pros and cons to it. And we're looking into the improved ways to do that. And if you're interested, always appreciate PRs migrating changes over from Go Ethereum. We do spend a lot of time doing this, and we also spend a lot of time verifying these changes because we have made some changes. And so making sure that none of the upstream changes break subnet EVM and core ETH does take a lot of time as well to make sure everything goes smoothly. So this is a large amount. This takes a large amount of time on the VM team for sure. Great question. Gives me anxiety, but great question.
Yeah. I mean, I think very briefly, like the burden of like upstream maintenance is something that a lot of people in the blockchain industry face because of like kind of the shared borrowing of work, we'll say, of everybody. And so first off, like, obviously it's not like the Geth team had this vision of like having 100 forks that maintain it, like rely on it deeply for what they do, right? Like, I don't think when they originally put up the code base, like the hope was to have all these L2s that like compile it into everything you could ever think of, right? So in the same way, a lot of the blockchains that run EVM run some derivative of Geth. And so, I acknowledge, and it's very clear that like making things easy to manage in all the forks is not a goal of theirs. And I don't necessarily think it should be. Like, that's not what they're trying to do. And so, the work that they've done is fantastic to like get the repo to this point and what it is for Ethereum. And this is why, another reason why it's so interesting to us to continue developing our own virtual machines, right? Like, if we're spending all these engineering resources, keeping like a downstream thing up to date, like, that's all a bunch of time we could spend making Warp easier to use or like connecting different parts of the network to each other in a better way, right? And so the more control we have over this, the better it is typically for the network's health, because we just have more control over the destiny of the way the network is, and really the community has more control, right? But like post merge, like a lot of the stuff going into the EVM is very merge specific. So like, right, like we don't have a beacon chain, right? So like making requests into the beacon chain doesn't make sense for like what we do, right? So, how do you reckon with that? Well, do you like modify everything in Avalanche Go to provide some notion of a beacon chain? Probably not, right? So then you start to diverge more deeply from what the EVM and Geth is doing. And so, maintaining compatibility ends up becoming very expensive and very difficult and error prone. So there's a lot of reasons why like getting on your own virtual machine that has a much simpler trusted code base that is more geared towards like the network you're building on can be much more powerful. Naturally though, people want the EVM. So it's a kind of a catch-22.
All right, thank you.
Thanks.
Yeah, thanks, Hagen, for that question. Our last question is going to come from Eric Forgy. Floor is yours, Eric.
Hey guys. So this is maybe not so much a question as it is like a call to action, because like it's pretty cool watching the Hyper SDK. I'm watching on GitHub, so like Patrick's burning up my inbox every day with tons of commits. So it's pretty awesome to see that the velocity going on, the development there. And then I think like I'm very interested in the token VM development. And like if you look at the GitHub repository, there's a discussion part. So I kind of opened up a discussion for I call it a hyper token standard. So like I think it's not too early for us as kind of DeFi people to start thinking about what a hyper VM token standard could look like, because I think EVM obviously was developed before ERC20. So like if ERC20 was there in the beginning, I think they probably would have designed the EVM differently. So like we kind of have an opportunity here to kind of rethink like what the VM should look like to be more native for DeFi type applications. And I think so like kind of something I want to start thinking about as a community is how do you do accounting properly? Because UTXO is pretty cool for certain applications, but I don't know if it's super great for DeFi applications. So like I think the alternative is to go to kind of TradFi. There's some good things in TradFi with, say, double entry accounting. So like one thing that's quite missing in EVM, which I think we can fix here, is this concept of a liability. So like everybody knows assets. There's a balance on the asset. A token has a balance. But like sometimes you have liabilities like lending, for example, insurance. These are DeFi applications that you're actually dealing with liabilities, and there's no such native concept in DeFi now of a liability account or a liability token. So like if you look at like lending protocols and Solidity contracts, etc., there's always kind of a complication because you have to treat liabilities differently. Like, oh, normally I would add a balance, but here I'm going to subtract it because this token is actually a liability. So there's like a bit of convolution happening in DeFi now, especially around liability. So one thing I want you guys to think about and kind of call to action to everybody listening is this thing about how we can actually create a better world for DeFi at the VM level, where you can actually handle things like assets, liabilities, contra accounts, this kind of stuff. So like, I think like you mentioned, like in the next call, we can talk about C chain, X chain kind of tokens. I think that would probably be a good place to start thinking about this kind of stuff. So it's not exactly a question, but like, I'm just kind of like, we have a great opportunity to build something right from the start. And it'd be kind of a lost opportunity because I kind of like, as excited as I am to see Patrick committing all these stuff, I kind of feel like he's having fun. And like, but like, I think a lot of people just grab onto what he did because it's like, oh, Patrick did it. And so like now if everybody grabs onto this and that, I think you're basically, without maybe thinking about it, developing a token standard yourself. And so like,
there's no doubt I'm having fun. That's a guarantee.
Yes. For sure. It's obvious, but yeah.
Yeah, I mean, I totally agree. So I mean, like these are like, for example, a token VM I consider still to be an example virtual machine, right? So like we'll use that virtual machine to do a bunch of the dev nets and like all the testing related to that. But I don't think I would say that I put enough thought into any of the standards that are used there that I would recommend that everyone do exactly what I did in the token VM. It's very much like I expect a number of these things not to work and then for us to entirely rip them out and change how we're doing it. Like that's expected as far as I'm concerned. And I want to make sure that's super clear. But I wanted, before I got into discussing what you're talking about, I wanted to highlight what Eric just mentioned, which is this discussions tab. So we don't currently do this on Avalanche Go yet or anywhere else, but there's this really awesome GitHub feature where you can go and just have like almost like a Reddit style discussion within the repo about anything. So you can post any sort of discussion and it's different than an issue. Like I feel like an issue is a clear action item or problem, whereas a discussion is more of like, hey, like what should we do here? So Eric posted a really awesome piece on like talking about the hyper token sort of thing and like what a standard may look like, where I filled in kind of what the token VM currently does. And so it would be great if we could have discussions, I think, around different aspects of the Hyper SDK or different ways to develop stuff. And so the two, major standardization things I think that we'll need are warp content. So like, what does the actual payload look like? And hopefully there's like some minimum number of arguments, and then kind of optional arguments that are maybe specific to different virtual machines that could be used. And then the other one is token formats. And so far, like I think the Hyper SDK is one level of abstraction below like caring about token formats. And so that would be something that really would be enforced by the virtual machine creator rather than the SDK itself. So the SDK itself, just as a reminder for people when we're talking about this sort of thing. So the SDK itself is a little bit more, it's a little less opinionated about this sort of thing. So like, for example, there is no notion of a token when I execute your action. So when the actual Hyper SDK says, hey, like, here's the thing you're trying to do, I'll execute it. Here's the database. Here's the authentication. There's no notion here of like, oh, make sure you spend 60, dog coins or whatever on this transaction. Like that's just not a part of it. The only notion in the Hyper SDK of anything fee related is in the authentication module, this section. So because the fee mechanism is actually run by the Hyper SDK, we don't impose that on the Hyper VM developer. The Hyper SDK also runs the mempool. So it needs to know for any authentication, who's the payer. So just like to make sure that there's not too many of the same payers in the mempool. It's like if you have 1 million transactions in the same payer, you may want to remove some of them to avoid a DOS. Second, can that person pay for what they're trying to do? So like just abstractly in the native, like, can they pay an amount? Cool, they can pay it. Later on, I'm going to actually have them pay it. And then after that, I'm going to refund them the payment if they like anything that they didn't use. So like I'm going to basically deduct the max fee of the transaction. And then after the transaction executes, I may refund them some amount that they didn't use. And that's it. So when we're talking about like token standards and how we actually integrate here, I think the hope would be that the Hyper SDK would contain like spec standards of like different sort of structs that people could use standard across different implementations of the VM. But I actually don't think it fits within the actual context of the virtual machine per se. You could extend this payer thing too to like have a can deduct and put an asset ID in here too to allow you to like pay in multiple assets if you wanted to. But again, like every time you do something like that, you just make it stricter, like and harder to do weird and wild things on top of Hyper SDK. So I try to be very light touch, at least in that way. Yeah. Good question. Thanks.
Awesome. Well, thanks everyone for joining our first inaugural developer community call. And thanks to everyone who came up and asked their questions. Thanks to Patrick, Aaron, and Steven for leading this discussion on Avalanche Go, Avalanche Warp Messaging, Hyper SDK, and everything else that we discussed today. This call is going to be watchable on YouTube on the Avalanche.
I think I'm going to take there's actually a few more questions I think that we collected that people that aren't on the call that we're just going to fire through a few of them if people have time. But Aaron and Steven, if you have other things you need to attend to, feel free to.
Steven, I think I have a call with you, so if you want to stay, I'm down to as well.
Yes, let me pose some of these questions here. Give me a second. There's about 15 of them, so I'm just running through them real quick. We're not going to handle all of them, but I just want to make sure we get some good ones. All right, here's the first one. This one I'll give for Steven. This one is from Jürgen Paul. Are there any plans for the future to create a formal specification for Avalanche Consensus Protocol and Hyper SDK, parentheses, like the Ethereum Yellow Paper? So it would be possible to implement the Hyper SDK or subnet clients or Avalanche in other programming languages.
That's a good question. I think that there's still a lot of work being done as far as actually nailing down the final design. So like one thing that we're looking at doing, and we've been talking about for a long time, is introducing like Frosty consensus and things like that. And so I think that there's still a lot of kind of like improvements and innovation that we want to do at like a pretty core level. And so I wouldn't want us to put a lot of time into the current structure. But I think that the final structure is also not fully known at this point in time. So it's definitely a good question at what point it would make sense to do that. I think it does make sense to do that because I definitely don't want Avalanche Go to be the only client that exists. And without a more formal spec, it's not fair to be like, well, Avalanche Go is the spec. So, you know, if you want to implement something else, just do what Avalanche Go does. It's like, okay, that's not reasonable at all. So yeah, I'm not exactly sure when it makes sense to do this, but I would definitely love to have that.
Yeah. I think on this point in particular, I agree that like it's not quite at the time. Like obviously spec writing is extremely important for like, you know, first of all, running kind of generic black box testing, but also for other client development. But at the same time, it takes an immense amount of time to get a specification fully correct and like fully describe what's going on. And so I think it's something that we will shoot for. And if someone is working on it already, we'd love to see it. But I think that we want to get a little further along with different sort of upgrades that are planned for the network before we try to codify them. Yeah. Cool. Yeah. Next question from Omar. I have a question regarding the Avalanche Warp messaging. So as far as I know, Subnet A sets a stake threshold, something like 80%, to accept messages from Subnet B. Can Subnet A also ask for a specific amount of Vox stake to accept messages from B? For instance, Subnet A accepts messages from other subnets whose validators have a total Vox stake of over 100,000. If AWM facilitates the types of checks, a whole new set of security mechanisms could be built across the network. I think that's a
great, phenomenal question. So this, I if you've been paying really close attention, there was a brief point where I talked about my manifesto of generalizing signature verification on the clients in warp messages. So right now, Avalanche Go gives you a nice tool or utility to verify a message. You basically just specify the percentage and that's it. That is actually fully client side of the VM. So what I mean by that is that the actual VM subprocess is the one that is fully doing that. And it's just using a utility from Avalanche Go. So that actual verification is not needed. You could implement your own verification completely as to whatever specification you wanted. Warp messaging is really just specifying what the payload is on the signing side so that Avalanche Go can do that signing and not expose private keys to any like subprocess. So what that means is that you can, using the p-chain height, you could just look up. Oh, so the way that the verification works is given the p-chain height, it looks up the sending subnets validator set at that p-chain height and then use that to perform the verification of the message. Rather than just doing that, you could look up the primary network's validator set as well and actually calculate what the total weight of the signers were on both the primary network and on the subnet at that point and perform your own verifications. So the actual VM is totally allowed to do whatever it wants as far as that is concerned. And so, yeah, this is completely and totally supported right now if you wanted to with a custom VM. Yeah. Great question.
Yeah, that's a good one. Next one, I think this is another one kind of on, actually one that we get a lot of questions about. Can you, I don't know who this is from, it just says the question. Can you explain your Avalanche Go versioning taxonomy? I.e., does vn+1.0.0 necessitate a hard fork? If v1.n+1.0 necessitate a soft fork? Like, yeah, maybe you want to give a quick update there.
Yeah, I'll also dive into this. This is also manifesto-y kind of thing. But so yeah, Avalanche Go versioning is pretty controversial because what is actually being versioned is hard for some people because people use Avalanche Go for various different things, right? So some people care about the HTTP APIs that Avalanche Go services. Some people care about the actual exported functions that Avalanche Go provides as a library. Some people care just about the actual like network as a whole, the P2P network on what things are compatible. So the short answer is that semantic versioning doesn't fit very well into something that is all of those things. You know, it's not just a library, it's not just an API, it's not just a client, it's kind of all of them. So if we were to take the union of all of them, every release we did would be a major upgrade. So we're not going to do that because that's useless. So the way that versioning works in Avalanche Go is we went from V0 major version to V1 when we released mainnet. We probably won't be touching that unless there is an extremely major network change that happens. So that is pretty much a constant at 1 at this point. And when we exactly would change that, if we do, is not very well defined. Whenever we increase the minor version, so the second point in, that constitutes a network upgrade. So anytime we say, oh, you need to update your nodes before this time, otherwise you might stop syncing the network, yada, yada, yada. That's because we pushed out a new minor version of Avalanche Go. And then any other release that is not a network upgrade is a point release. So it's the patch last number, and we just increment that by 1 every time. So that's how Avalanche Go does versioning. So essentially, we focus on the actual like Avalanche network when we do versionings. Yeah.
Cool. And then the last one, which will go for Aaron, is related to EIPs. And so the question is, as we're, maintaining the different types of EVMs, like how do we think about which EIPs to include and not include?
Sure. Yeah, so we try to include all of the EIPs that will be relevant to smart contract programmers and developers and users on Avalanche. So that means things like withdrawals. where we have no beacon chain, we have no withdrawals that would be related to more E2 type of stuff. We're not including any of those, but everything else we would like to try our best to try and include. So for the most part, this means that almost every AIP gets included. There are a couple of exceptions to this. So things like the randomness beacon, that's part of the beacon chain. That opcode is still using the previously used value, which I believe is just that block hash, if I recall correctly. Or actually, no, it's not the block hash. It's the difficulty of the block, which in Avalanche is just 1. So it's not a good value to use, and you shouldn't really be using that opcode on Avalanche in the same way that you would on Ethereum. It was sort of a weak source of randomness before, and it's a much stronger source of randomness since ETH2, or will be when that gets merged. Not actually 100% sure there. For things that are related to withdrawals, those obviously won't go in, and things like EIP 4844 that are going to have more interactions with the consensus client of Ethereum, those will start to become more difficult to include. I think some people have actually tweeted about this, that this may be more difficult for various Ethereum forks to continue to maintain parity with Ethereum as Ethereum goes further down this path of a separation between the execution and consensus client. For subnet EVM and Core ETH, we obviously don't have that parallel. We do have a consensus client, but it's not providing the same utilities that a normal Ethereum post-merge consensus client would provide and would plan to provide. So for EIP 4844, this is obviously a very big feature on Ethereum, and we would very much like to include something that is similar to it, but it won't look exactly the same. So although we'll always try to maintain parity, there will definitely be some EIPs like withdrawals that just won't make sense. And then some EIPs that, based off of different things Ethereum is doing, we'll sort of have to make a decision on how we support that and exactly how it might look differently. So it's a bit of a case-by-case basis.
Cool. All right. Thanks, Aaron. Yeah. So we had a lot of fun doing this, at least. I hope you guys enjoyed it too. So there's a ton of questions here that we unfortunately didn't have time to get to. I think we could sit here for hours, but we'll preserve these questions for the ones we didn't get to for next time. Maybe invite some more folks up to ask those. Thank you for submitting your questions, and pains me. I think of the ones that I see listed here, we got to, I think, 5 of the 16 or 17. So, I think there's a lot of work to do here. So we'll come back to that and maybe have another session sometime soon. So, thanks for joining. Usman, if you want to take it from there.
Yeah, this call is going to be you're going to be able to watch it on the Avalanche YouTube channel. We're going to have another community call hopefully in a couple weeks. And then in the meantime, if you want to discuss things with myself, the other members of the DevRel team, or just other members of our team in general, we host weekly spaces called In the Labs on Twitter every Thursday at 12 p.m. Eastern. So you can catch us there. And until next time, guys, we'll be back soon.
Thanks, everybody. See you later.
Thanks, everyone. See you guys.